Hello, welcome. Let's try to solve another Leetcode problem. 1835. Find XOR sum of all pairs bitwise add. So what is this meaning? So we are giving two arrays. So the length of the array is going to be more than or equal to 1, less than or equal to 10 to the power of 5, and the value is going to be 10 to the power of 9 to 0. Yeah. So we want to do such kind of calculations. So first of all, it's gonna be the add calculation. So for this one, gonna add 6, and this one gonna add 5, and similarly for this two, gonna add 6, and 2 gonna add 5, and 3 gonna add 6, and 3 gonna add 5. So this gonna be the bitwise add operation. So after we get the result, we're gonna use the XOR operation to mix them and together. So between them, we're going to use the XOR operation. So this is going to be the final result. It's going to be 0. Yeah. So the problem is actually the title. We need to find all XOR sum of all pairs bitwise and. Yeah. So definitely we cannot use the brute force because the length of. So definitely n squared didn't work. Yeah. But instead of doing it in the time complexity of O(n) square, we're gonna try to reduce the time complexity. Yeah. So instead of just using the brute force to check each of the pair, so we're gonna check each of the bit. Yeah. So for the integer, maximally it's gonna be 10 to the power of 9. It means it's gonna have 30 or 33 bits. It doesn't matter. Let's just make it 30 or 33 bits. Yeah, so we just check each of the bit. So for example, at this bit, for this number maybe 1, there's a 0. Maybe 2, it is a 1. Maybe 3, for this bit it's gonna be a 1. Yeah, this is just the example. Maybe for some numbers, maybe for 6, for this number in array 2, for 6 maybe it is a 0. For 5 at this bit maybe a 1. Yeah. Now what are we gonna do? Because we are not going to use the brute force, we're gonna just check each of the bit. Because the final result is determined on each of the bit. This bit may be a 0, this bit may be a 1. Yeah, now let's just check this bit in between. So in the middle. So in the middle for this bit, this is 0, XOR 1, XOR 1, it's gonna be 0, and then XOR 0, it's gonna be 0, XOR 1, it's gonna be 1. So this final result is gonna be 1. Yeah, maybe for this bit 0, 0, 1, 1, 0. So for this bit, it's going to be 0. Yeah. So what's going to be the final answer? The final answer is going to be here. Yeah, maybe something to 1 to 0 and to something. So this is going to be the final answer. So instead of calculating them by using the brute force to calculate each of the pair, we're going to calculate each of the bits because this is going to be easier. And the time complexity is going to be n times 30. So that is why it works. Yeah. Now let's just try to use this method to solve the problem. So I'm gonna prepare a final result, and then I'm gonna check all the possible bits. So let's say for I from 0 to, let's just check it with 32. I think that is enough. So we're gonna prepare two counters. This counter is just check for how many bits at this position for array 1 and how many bits at this position for array 2. Yeah, we just accumulate all of them. So if you check the example, so above this line it's going to be how many bits in array 1, and below it it's going to be how many bits in array 2. We just accumulate all of them, and then we're going to use the multiplication to check. Yeah, because if this is odd, the sum of them is odd, and this is even. So what's going to be the final result? So how many pairs? If this is odd, this is even. So the final result is going to be even. Yeah. If it is even, if this is even, and if this is even, the final result is going to be even. Yeah. But what happens is if this is odd. So for example, above it I have only one set bit 1, and below it I only have one set bit of 1, and then I'm going to try to do the pairs. So how many pairs? It's going to be 1. If this is a 3, for example, and this is also 3, so it's going to be 3 times 3, it's going to be 9. Yeah, so this means how many pairs? It's going to be 9 pairs. Yeah, so basically it means this is 1 1 1 and here is 1 1 1. I need to choose all the pairs. Yeah, this one, choose this one, this one. Definitely it's going to be odd pairs. If it is odd, definitely I need to calculate it. I need to use a set bit 1 for my final result. If it is even, I don't need to do that. Yeah. So this means I only need to check above it for array 1, the set bit, the number of the set bit is going to be, the total number of set bit is going to be odd, and similarly for array 2. So let's just calculate it. So C1 going to be 1 for all the numbers. So all the numbers in array 1. Let me check if it is a set bit, right? So if this number, let's just use left shift, right shift. Yeah, so it's going to be right shift, I. So I gonna be starting from 0. So we're gonna check each of the bit and 1. Yeah. So the meaning of it is that I'm gonna check this bit. If this bit is 1, it means it is my set bit. Yeah. And similarly for C2. So C2 are going to be sum of 1 for n in array 2. So if n right shift I positions at 1 equals to 1. If it is valid, so I'm gonna use a set bit 1, and then I'm gonna sum up all of them. Yeah. Now I just need to check if it is even or odd. Yeah. If C1 modulo 2 and C2 modulo 2 equals to 1, so definitely I can get the final result. Yeah, because definitely I want to check all the possible pairs. Yeah. So if this is odd and this is odd, so this means the final pairs of the XOR operation gonna be odd. Yeah. If it is odd, it is okay. It means I need this bit. Yeah, I needed to put it in my final result. So this means the result gonna plus equal to this one. It's gonna be right shift I. Yeah, basically this means I need to yeah, let me think about it. Yeah, so here I need to use one left shift I. Yeah, basically I need to this means I need to use this bit. Yeah. Now let me just return the final result. As you can see, it works. Yeah. So what is the meaning of here? So this is for right shift. This means for any number, any binary number, I need to check each of the bit. For example, this is a binary number. And for n right shift I, first of all, I'm gonna check this number and then this number. If this is a set bit, this is a 1, and the total C1 gonna be odd. Yeah, this means if this is odd and the C2, the total sum is also odd. Maybe this is 3, this is also 3. So I need to use this set bit. How can I use this set bit? I just need to plus it to the final result. So this means 1 gonna left shift I. So from the beginning, this is a 0, this is a still 1. Maybe I equal to 2, it's gonna be 4. It's gonna be something like 4. And then we're gonna plus them together. And this is gonna be the final result. Yeah. Now let me just submit it to check if it works. Yeah, as you can see, it works and it's passed for all testing cases. And the time complexity is n times 32. Yeah, because as you can see, this is only a for loop, this is 30. And for here, this is O(n). So this is why, yeah, it always works. So maybe this I, we do not need to set it to 32. Let me think about it. Yeah, let me check which number is bigger. So for example, I'm going to use a 2 to the power of 29 maybe. I'm going to check if it is more than 10 to the power of 9. Yeah, let's also have a check. So this is false. So this means that 2 to the power of 30 should be more than this number. Yeah. Yeah, as you can see, 2 to the power of 30 is going to be more than 10 to the power of 9. So this means we only need to use the 30 bit instead of 32. Yeah. But for this I, if this I equal to 1, it means 2 to the power of 1. If I equal to 30, this means 2 to the power of 30, right? So from here, basically we need to use a 31, and this is enough for us to solve the problem. Yeah. So now let me just run it and submit it. Yeah, as you can see, it also works, but it didn't reduce too much of the time complexity. But if we use 30, definitely it didn't work because that is not enough. Now let me just submit it to check. Oh, it also works. I don't know, maybe the testing case is not okay. Yeah, let's just check 29. Definitely 29 didn't work. Yeah, let me check this number. Yeah, as you can see, 29 didn't work. Yeah, but for safety, let's just keep a 32. I think that is big enough to including all the testing cases. Yeah, I think that's all.